Okay, so this is the key. It says mole quiz on the top left-hand corner. And just follow along. So question number 1, what's the empirical formula for the substance? So the empirical formula is going to be the one that is most reduced. So we have 2 different elements here. We have S, and S is 40.05. It says 40.05%, okay, but part of the rules of what we learned, and this was an open note quiz, that the percent really is the grams. And then step 2 is to convert the grams to moles. So that's for sulfur, and the grams of sulfur on the periodic table is 32.006. Is it 066? Okay, so we're going to divide these 2 numbers in your calculator. It does not need to be in scientific mode. 40.05 divided by 32.066, 1.24. Okay, and the next part of this pie was oxygen, but it didn't give us the percentage. How would we find out how much oxygen is present in this pie? We would take 100 minus sulfur. So 100 minus 40.05. 59.95 is the rest of this. And this is grams of oxygen, so then this is grams of oxygen. Okay, so we're going to take the 59.95 divided by the mass of oxygen, which I got off the periodic table, and it gives me 3.74. Does anybody remember the next step? What do we do after we found our moles? We're going to divide by the smallest mole. So every mole you found, let's say there are 4 or 5 different elements, you would still divide by the smallest mole. And we now have our new subscript. So for S, it was just 1, which you do not have to put the 1. And then for oxygen, it's 3. So if we look at our answer choices, and I got that from this. So those numbers that you get by dividing by the smallest mole are your subscripts. So for SO3, it would be C. Anybody have questions over that one? Okay. Let's look at number 2, which is the correct molar mass for the compound CaBr2. So the mass of Ca is 40.078. And for Br, there's 79.9. 149? 159. Okay. So those 2 numbers I circled there, the 40.078 and the 159, you need to add those together. Because the 40 accounts for how much calcium weighs. Okay, and then the 159 is how much 2 bromines weigh, because it says there's 2 of them right here. So don't forget that step. So you just simply add them all together. It doesn't have to be in scientific mode. Also, how I keep all the decimals, you don't have to do that. I recommend just keeping 1 decimal. So when I add them together, I get 199.078. So C is the closest answer. Okay, how many grams are in 1.946 moles of NaCl? So I start off with 1.946 moles, and I want grams of NaCl. Because this says moles, moles has to go down here. I'm going to put a 1 there. Where am I going to find grams of NaCl? Yeah, on the periodic table. So the mass of sodium, 22.9, and chlorine, 35.4. I simply have to add those two together. $58.35. Okay, so I have my chart set up. Am I multiplying or dividing? These two numbers are side by side, so I'm going to multiply them. When I multiply those two numbers, I get 113.199. So it looks like this is the best answer, A. Okay. Any questions on that one? Go ahead and look at number 4. How many moles of carbon? And then that gives us a number. So what do we want? It says moles of carbon. They only gave us one number in the problem. Because this is molecules. Molecules is going to go right down there too. They have to match. What number always goes in front of molecules? Avogadro's number. Or 6.02 times 10 to the 23. You can even say 6.02 E positive 23. So are we multiplying or dividing these two numbers? Dividing. You may want to put it in scientific method or scientific notation. 3.79 times 10 to the positive 23 divided by Avogadro's number. 6.02 times 10 to the 23. Okay, so I got 0.629. Let's look at my answer choices. So there it is in A. I'll show you my calculator again. I don't see any little exponents hanging out over here at the bottom. The correct answer is one of the choices, so you should have put A. Which term is this? Number 5. Which term is described as the lowest whole number ratio of elements? So the lowest whole number, though. Sometimes they say the most reduced. What do you guys think? Empirical. Number 6, find the empirical formula for the compound that's 70% iron, 30% oxygen. Again, those percents are the grams. So just change grams to moles. Where would I find grams of Fe? Where do I go to find those numbers? I just get it off the periodic table. So now I divide, that's 70, divided by 55.8. I do the same here. I divided them. This gives me moles. I just converted grams to moles. I divide by the smallest mole. when I divided this one, I got 1.5 as my new subscript. Can we leave 1.5 there? No. When it lands on a half number like that, what do? We multiply both of them by 2. So the new subscript for iron, it's Fe2O3. Fe2O3. So nothing's gonna cancel out there. It should be Fe2O3 is the final answer. So that looks like it's C. So number 6, C. If we look at number 7, how many grams are needed for this many moles? You get one number in a problem. That one number in the problem is what you write down. We have to find the mass of this CCl4. So C is 12.011. Cl is 35.4. But we have 4 of them. 153? I got 141.6. So I'm typing in 35.453. 141.812. Okay, so I need to add these two together. So the mass of CCl4 is going to be 153, the total mass. Oh, okay. So I'm going to multiply across and divide by the bottom. So 5.000 times 53.8. It gave me 269. I'm still going to divide. Oh, it shouldn't say 5. Sorry, guys. Just call me out when I make a mistake. Wait. Oh, look what I did in my calculator. I forgot the 1. So that doesn't make sense. So the final answer is 769. Okay, let's take a look at number 8. Again, this is just more conversions. The more practice you have, the better for the exams. 0.20 moles. If this is moles here, it has to be moles here. I'm just going to put a 1 in front of moles. Grams of water. 18.0, I think. 02 maybe. Okay. So, oops, I put it on the wrong side too. So that's grams of water, H2O. Okay, so this is the number that's given in the problem. It's always going to go in the top left box. These units, top and bottom, always have to match. The rule is the number 1 will go in front of mole. And what we're looking for goes on the top right. So that's why I put grams of water. Okay, so you're going to multiply the 2 side by side. .602. So the correct answer would be B. Let's look at number 9. You only have one number in that problem. You have to look up the mass of NH3 on the periodic table. Has anyone already done that? Okay, so am I multiplying or dividing? You are dividing. When you divide them, it's 6.29. I would say C. Let's go ahead. Any questions on that one? Let's look at number 10. Okay, number 10 says, what's the percent composition of CO? So that's really carbon monoxide. Okay, so you need to find the total mass. The formula for this is part divided by whole. So the total mass of CO and then when you add those together, $28. So that's always going to be your denominator because you're going to do it for each individual part. So carbon, it's 12 grams carbon, so 12 divided by 28, 12.01 divided by 28 is 0.428. I'm going to multiply that by 100 to turn that into a percent. So carbon is 42.8%. And if you didn't want to do any math for oxygen, then just subtract 100 minus 42.8. So it should be 100 minus 57.2. So D. Again, let me walk you through these percent compositions. No matter how big or small the formula is, you get step one, find a total mass. That's always your denominator. Then each individual part, for the next one for copper and then for 2 chlorines, you put the mass of copper divided by the total weight of the compound, and then you put the mass of 2 chlorines divided by the total. Okay, and to turn it into percentage, you multiply by 100. So copper weighs 63.546. Chlorine, how much does it weigh? 70. Okay, and that's for 2 chlorines. I'm going to zoom in. Okay, because again, I'm looking for the mass of this. 1 copper and 2 chlorines. So that mass, the 70.906, is 2 chlorines. So now I just need to add those together to get a total mass. And that's 134. I'm kind of running out of room. I think I'll do it right here. So I know that's going to be the denominator for both of them. And then I put their individual weight on top. What does it equal?
47. Yeah. 46.
Okay, so these are roundabout numbers that we can see the answer. So then it's going to be D. Okay. Any questions on how to find percent compositions? Okay, number 12. The way I set this up, I just put that one number that they gave me in the problem. Goes on the top left, 132 moles, because that says moles. This has to say moles, the roll for mole. go ahead and put a 1 in front of it. It wants the number of atoms. Anytime you see atoms, molecules, ions, pieces, particles, use Avogadro's number. So are we multiplying or dividing this? Multiplying. So it's 132 times Avogadro's number. Okay, I see 7.9 times 10 to the 25. So the answer is C. So actually all the answer choices were there. Now that we worked through them all. You guys want me to go through these on the back? Are you guys okay? Okay. Well, if I had the answer, I'd give it to you right now, but I'll work them out while you guys are working and then write down the answers. Okay. So I will give you the answers to these short answers. I just haven't worked them out yet. Just hold it for right now.